Everyone is talking about Industry 4.0 and IoT, Internet of Things. However, in order to make machines or even entire factories networkable, the components in the machine must first learn to speak and permanently provide the higher level controller with information about their own status. Many components are still dumb mechanical parts in this respect, which hinders the implementation. My name is Andreas Merz. I'm Product Manager for Electrical Components at Meyer Power Transmission, and I will show you today how we make electromagnetic brakes speak. When electromagnetic brakes are switched, characteristic curves become apparent, shown here in simplified form as current, blue curve, and voltage, green curve. The course of curves allows conclusions to be drawn about the operating state of the brake and the wear. If, for example, the two peaks in the blue curve are missing, the brake has not switched, despite the current being applied, and an error signal is output. The robo brake checker is connected directly into the brake supply without additional sensors and monitors the brake. The actuator itself becomes a kind of sensor. Since the robo brake checker module operates from the control cabinet in a protected environment, ambient conditions on the brake, such as dust, dirt and temperature, have no influence on the reliable function. In contrast, initiators and microswitches could generate phase signal due to the contamination and would have to be checked or cleaned from time to time. The elimination of sensors, including cabling, especially in unprotected areas, therefore increases reliability and prevents downtime. In an extended version, the robo brake checker module is equipped with an additional board with customer-specific interface, such as optical, wireless LAN, I/O link, Profibus, and so on. Via this interface, the module can provide data on switching time, current voltage, resistance, and power. This also makes it possible to evaluate sequences. Conspicuous features in the process can be quickly recognized, and thus conclusions can be drawn from complex interrelationships. This is an advantage not only for the predictive maintenance, but also for the interaction of robots, transport, and warehouse logistics. Furthermore, integration into remote maintenance systems is possible. The output of extended data thus opens up a lot of new possibilities. Due to its advantages over conventional brake monitoring, the standard version of the robo brake checker is already in use in over 30 industries worldwide. There is a noticeable increase in demand for versions with extended data output. Thank you for your interest in the robo brake checker. We have linked more information for you here under the video. Stay innovative and goodbye.